Hi, today we are going to discuss about probability. This probability topic is very much important in statistics because the total machine learning and data science, artificial intelligence itself, it is depends on the probability. Because what we are doing in machine learning or artificial intelligence, we are just predicting for future. Means predicting by taking the statistical data or previous data. Okay, by taking the previous data, we are predicting the future. For the purpose of predicting the future, what we are predicting, how we are predicting, just a probability. In previously, what happened, based on what is the probability of getting that event occurs in future? That is nothing but probability. So, what is the definition of probability? Probability is a measure of likelihood of event. What is this likelihood? Likelihood means nothing but how much chance is there to happen this event, and also how much will happen. Suppose probability of raining tomorrow. How much probability is there? Will it rain or not? To predict tomorrow, what we are doing? Today's weather conditions and previous weather conditions we are taking into the consideration. So it is probability is very much important topic. So total artificial intelligence or prediction, everything is depends on probability. So what is a probability? Probability is measure of likelihood. That is nothing but chance. How much chance is there? Suppose a small example, a coin will be there, right? A small coin or cowrie. It is a cowrie. We can use or head and tail will be there. Okay. If I drop this cowrie, what will happen? Either it will show the head or show the tail. Okay, how much probability to get the head? How much probability to get the tail? Okay, is there any other probabilities are there? No. But here for a funny example I am showing here. See here, it never happens. It never happens. Cowrie will not stand. This is a third option. But either this way or else in another way, this way will happen. Right? For coin, for toss, if we toss a coin, what will happen? Either head or tail. Only two ways are there. For suppose it is a die. If we roll a die, how many faces will be there for die? There are six faces. Okay. With 1, 2, 3, 4, 5, 6 dots, there are six faces will be there for any cube. So there is a chance of getting the six outcomes. It may come one or two or three or four or five or six also. There are six outcomes in this die. For coin, how many outcomes will be there? Only two outcomes. So in two outcomes, head is one, another is tail. To get head, how much of probability is there? It is 50% because to get head, only two outcomes. So this probability is 1 by 2. In the same way, if I roll a die to get, suppose two number I have taken. What is the probability to get a 2? 2 is only one face, but there are six faces are there. So 1 by 6. 1 out of 6. So 1 by 6. So that is the formula of probability to calculate the probability of formula. Okay. Probability of A. P of A is nothing but probability of A is number of times A occur. How many times it occur? Okay. How many times it may occur and total number of possible outcomes. Totally how many outcomes possibility is there? Okay. If we toss a coin two times, how many times it may happen? Two times. And also, how many outcomes will be there? Because two times we have tossed the coin, means total four outcomes, right? So 2 by 4. Again, it is 1 by 2 only, right? 50% of chance. Here, 1/6 of the chance will be there, right? So That is a formula of probability. But in probability, up to here it is very simple. But in probability, what we have to keep in our mind means these are the very much important things. Probability, we should not get confused. We should not mix each other things. Addition rule and mutually addition rule for both the things. Mutually exclusive, mutually non-exclusive events, and also multiplication rule. Okay, this is the addition rule. This is a multiplication rule. In multiplication rule, what will be there? Dependent events and independent events. That's it. In addition rule, there is a addition rules are there for mutually exclusive events and mutually non-exclusive events is different. In the same way, multiplication rule has to be applied when for dependent events and independent events. Okay, these two things clearly, what is mutually exclusive or non-exclusive, what is dependent and independent events. Then when to go for addition rule, when to go for multiplication rule. Based on that, Bayes theorem will be, we can conclude the Bayes theorem. That's it. For data science purpose, in the probability, these are the very much important. More than this, nothing is there also. Let us try for one after another. Okay, what is the addition rule? When to go for addition rule? See, this is the addition rule. When what I said, addition rule for mutually exclusive and mutually non-exclusive events. What is the mutually exclusive and mutually non-exclusive events? First, we need to know. What is the mutual exclusive? See here. This is A and B. Both the Venn diagram it is. Okay. In this diagram, there is no connection between the A and B. Okay. This is called as a mutually exclusive events. Okay. For mutually exclusive events, so both the things at a time never happens. That is called as a mutually exclusive event. Suppose what is the mutually exclusive event? Tossing a coin. Again, we can go for tossing a coin. What will happen? At a time, two things will not happen. Either it will show head or tail. At a time, both cannot be happen. Then it is called as a mutually exclusive. If a die, if I have taken a die of this thing, 1, 2, 3, 4, this die, 6 faces will be there. Either it may come 1, 2, 3, or 4, 5, 6. But only one thing will happen at a time, 2 and 3 won't happen. So that it is called as a mutually exclusive events. Okay, so if the mutually exclusive events, what is the probability? Probability of dice showing 2 or 5. 2 or 5. 2 or 5. When what saying? Because 2 and 5 at a time, anyhow, it won't happen. So it is mutually exclusive at a time won't happen. 2 and 5 will not be there. So always R only will be there as it is a mutually exclusive event. So to get the 2, what is the probability? That is 1 by 6. In the same way, it has to get 5. It is also having the only 1 by 6. But total, how much probability? Either 2 or 5. So we are selecting 2. A person is saying, suppose it is a cricket or kabaddi, whatever it, people use it to give a toss. Because there are only 2 teams will be there, so they never use the dice. 6 faces die they won't use because only 2 teams are there. One team has to select the head, one team has to select the tail. So it has to be only either tail or head will come. So if there are 6 teams are playing, then what will happen automatically? First who has to go for playing, then dice may be taken. Because there are 6 faces, 6 teams are there. But suppose there are only 2 teams. Okay, India and Pakistan, suppose. India and Pakistan, suppose. They are going cricket, but there is a coin is not there, suppose we can think. They are using the dice, rolling dice. Okay, 6 faces rolling die. Okay, But 1, 2, 3, another side 5, 6, 7, 5, 6 also there, 4, 5, 6 also there. Then India selected, I am selecting 1, 3, 5, suppose. Pakistan selected 2, 4, 6. So what is the probability of getting the one, either 1 or 3 or 5? If 1, 3, 5, whatever it comes, India is going to take the batting, suppose. Yes, it is an example. Just to understand the concept of the example. It never happens. Okay, but Pakistan taken 2, 4, 6. So either 2, 4 or 6, anything in this 3, anything it may happen, Pakistan will take the batting, suppose. So what is the probability of getting the 2, 4, 6? What is the probability of taking the 1, 3, 5, getting the 1, 3, 5? Suppose, see, how to calculate that? For getting 2, what is the probability? 1 by 6. For 5 also, 1 by 6. Either 1 or either 2 or 5. So just we have to add. This is addition rule only we have to implement here. Because these are mutual exclusive examples, right? So 1 by 6 plus 1 by 6, it is nothing but 2 by 6, it is nothing but 1 by 3. So there is a lot more probability. If he selected only one number, only 1 by 6, but we have selected two numbers, so probability is increased. If just for our example 1, 3 or 5, what will happen? 1 by 6 plus 1 by 6 plus 1 by 6, totally 3 by 6 equal to 1 by 2. 1 by 2 probability, because out of 6 outcomes he selected 3 outcomes. 50% outcomes he has selected. So probability also 50% is happened. For this, in the same way for Pakistan also, either for 1, 2, 4, 6 also, what will happen? 1 by 2 probability, 50% of probability will be there for both the teams. So for mutual exclusive examples, we have to go for addition rule. Right. And what is a mutual exclusive and non-exclusive? Non-exclusive means, a mutual exclusive means at a time both cannot be happen. Okay, right. Then we can go for mutually non-exclusive example so that you will get the clear difference between the exclusive and non-exclusive. Suppose, yeah, this is the formula. Mutually, non-mutual exclusive events. Okay, non-mutual team, right? Mutually exclusive events. Yeah, this is the first. What is the non-mutually exclusive events? Means at a time both the things can be happen. Suppose a deck of cards. Deck of cards I need not to show to anyone, I think. But even though, let us see in deck of cards, what will happen? Color will be there, number will be there, a symbol will be there. There are three things will happen at a time. Even see here. This is what is a card? This is jack. This symbol is jack. Okay, symbol is jack. And color is black. Color is black. And what is the name of this card? Name or number? Number is 3. See, number is 3. So at a time, what we can say? It is 3, black color, jack. Suppose just a color, keep it aside. What is this? It is jack and also 3. I am saying here heart and kings. Okay. Heart is shape. King is the nothing but number. It is also we can denote for one number only. But in our example, heart shapes are there. Yeah, this is the heart. This is heart shape, and this is the jars and flowers. Different shapes are there. Okay, but what we are doing here? Only hearts, heart, and also king. King is nothing but it is a it is not symbol. It is a number. but heart is a symbol. At a time, both can happen simultaneously. What is this happened? King as well as heart. So if we say mutually exclusive events, either kings or queens, will it happen at a time? If it is a king, it may not be, it will not be queen. If it is a queen, it will not be king. But what we are doing? King, one is a shape. Shape and also number we are taking. So at a time, king as well as heart, both the things are happening. These type of events are called mutually non-exclusive events. Both the things can happen at a time. So that what to do? And hearts and king. Also, there is a probability. There is a possibility of heart simultaneously. It has to be king. So together is only one king heart. See here, how many hearts are there totally? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 hearts are there. But how many kings are there? 1, 2, 3, 4. 4 kings are there. But one is there. This K with heart is calculated, is added to this group as well as this group. Kings group as well as hearts group. We have added this. So that is a mutually non-exclusive it happened. Let us go for the formula. See here very clearly it is mentioned. Total 16 cards. Yes. How to get the total 16 cards? 13 hearts are there. Yes, 13 hearts. And 4 kings, 4 Ks are there. But totally how much happened? 17 cards has to be happened. Why? This K with the heart is included in both the ways. So what to do now? This king with the heart shape, we need to either in this group or this group, we have to add. One side we have to eliminate. So here it is added here as well as here. So one time we need to subtract. Okay. One time we need to subtract. So that what will happen? What is that? Probability of A or B equal to probability of A plus probability of B. That is a wrong notation is given in this. Okay. It has to be intersection. And means. Yeah, A or B. Yeah, right. No confusion. Probability of A or B. Probability of A plus probability of B. Okay. Minus probability of A and B. A and B, what is that A and B called? And means intersection part. This intersection part, once we have to subtract. Right. So and is nothing but intersection. Union is nothing but R. Okay. P of probability of A or B is probability of A plus probability of B minus probability of A intersection B. Did you understood? This is the mutually exclusive and mutually non-exclusive events. This is non-mutually exclusive events. Probability of A or B equal to probability of A plus probability of B minus probability of A and B. That intersection part has to be subtracted. But if it is mutually exclusive events, what is that probability? It is very simple rule. Probability of A or B, probability of A or B. Okay, it is an addition rule. What will happen as it is a mutually exclusive events? Probability of A plus probability of B, because there is a no intersection part is there to subtract. Complete A, complete B. That's it. It is very simple. If it is a mutually non-exclusive event, then only we have to, this extra thing has to be happen, that intersection part need to subtract once. Okay, because it is added in two ways. A very simple logic, right? Then what is the dependent and independent events? Now we are going into the multiplication rule. So when to go for multiplication rule? Because if even it is a mutually exclusive or non-exclusive, at a time we are taking, what is the total probability of it? But here, two events are happening one after another. Independent and dependent, by saying itself, dependency of one event on other event. Okay, so we can go for this example directly. How many, this is a bag, this bag is having the marble. Okay, these are the round marbles are there. These are the kinds or carom kinds, we can say whatever it. Okay, so how many kinds are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are 10 marbles are there, round marbles. In these marbles, these are the black marbles are there. Two black marbles are there. Another are different colors. Okay, 1, 2, 3, 4, 4, 4 white, 4 blue, and 2 black marbles are there. Now we can say, what is the probability of picking up? Just by keeping hand inside, I want to pick one card, but that has to happen a red color marble, or red, not red, black color marble. What is the probability? Simply saying, out of 10, how many black marbles are there? Only 2 marbles are there. So 2 by 10. Up to here it is okay. 2 by 10. And once again, this is the independent event I am saying. Independent means simultaneously 2 times it is I want to do. 2 times, not 1 time. Again I kept. See here. When you put first marble back into the bag, again I kept. So second time also, what is the probability? First time is 2 black marbles are there out of 10. Second time also again 2 marbles are there out of 10. So this time also no change, 2 by 10. But what is my probability? What is calculating? What I am calculating? Consecutively, 2 times I have to get a black. Is it possible? Yes, possible, but very less probability. At least 1 time we may miss. So how much probability is there? 2 by 10 is nothing but 1 by 5 into 1 by 5. Sorry, 1 by 5. It is 1 by 25. Because very less probability will be there. But here I am not interested in, is it less probability or more probability. But the thing is that just to have to multiply each other. So that 1 by 25 it will come if it is an independent event. Okay. Now what is the dependent event? The dependent event is nothing but first time I have taken. Suppose I got a black marble outside. Then how many will be there? How many marbles will be there in the bag? Only 9. Okay. Out of 9, how many black marbles are there? First time we got the black marble that I kept aside. So only 1 marble will be there. Only one black marble out of 9 other marbles. 9 all marbles, including black also. So 1 by 9. So now this is 1 by 5 into 1 by 9. How much it will get? 1 by 45. That is very less probability. See that just. This is the dependent event. This is the difference between the dependent event and independent event. Here there is no dependency. First time we got the black marble, again we kept inside. So second time event is not at all dependent on first event. But here what happened? First time black marble, as I got the black marble, what will happen? Automatically, the second time probability is very less because only 1 marble is there out of 9. Right? Suppose if I get another marble first time, so 2 by 10, 2 by 10, it's okay. 2 by 10, it's okay. In multiplied by 1. Instead of 1 by 9, what will happen? Suppose I got this marble, white marble from the bag. If I got white marble, what will happen in this dependent event? What will happen here? Two marbles will be there like that. Two marbles by 9. One marble is out of it. One marble is out of it, that is white marble. Again, luckily, two marbles will be there. 2 by 9, sorry, 2 by 9 into 1 by 5. Am I correct? Right. So, what is the probability of it? 2 by 45. So, the second total probability is 2 by 45. You are getting my point, right? So, purely the second event is changing based on the first event. So, it is called as a dependent event. So, if it is a dependent event, probability calculation will be like this. And if it is independent variable, this is directly we have to multiply. Here, probability for second time automatically will get changed. Okay, right. Based on this, Bayes theorem is applicable. Bayes theorem is happened. Okay. Suppose what is the main difference between multiplication rule for independent event and dependent events? Let us see. When two events are independent, the probability of both A and B occurring means A and B. What is this A and B? Just nothing but it is a events, first event and second event. Okay. So as we are saying it is a and B at a time. 2 times consecutively it has to happen, right? So then we have to go for multiplication rule. P of probability of A and B consecutively need to happen, right? Probability A multiplied by probability of B. So this is nothing but just we have seen, right? Either two continue consecutively 2 times it has to happen means it is 1 by 2 into 1 by 6. That is 1 by 12. What is this? Joy tosses a coin, then rolls a die. One time he is tossing a coin. Second time what he is doing? Rolling a die. So in coin what has to happen? Head. He need head. And second time 4 has to come from die. So 2 things has to happen continuously. So for getting a head it is a 1 by 2. Second time it is a 1 by 6. Because there is no dependency between the die and also head. Die and coin. Okay, this is multiplication rule for independent events. But here it is a multiplication rule for dependent events. Just now we have seen that marble bag. When 2 events are dependent, the probability of both A and B occurring is probability of A and B is probability A into probability of B by A. What is B by A? B given A. B given A means what is the B given A means if first event if happened in this way, what is the probability of B? If first time black marble came out and we kept aside, what is the probability of second time event? Automatically it comes to 1 by 9, right? Just now I have seen. Sorry. So based on this is nothing but conditional probability. See here, independent events, probability of X intersection A and B, nothing but X and Y, X intersection Y equal to probability X into probability of Y. For dependent events, what is that? Probability of X intersection Y equal to probability of Y, probability of X bar Y, X by Y, or X given Y, we have to say. Sorry. Y given X, Y given X means X is happened in what way happened, based on that Y probability will change. That need to be multiplied 1 by 9. 1 by 10 into 1 by 9 in our example. So with the help of this, what we can conclude it, Bayes theorem is nothing but what is, I am interested about this probability of P x by y. Probability of y given x. Probability of y given x. Okay. So I am interested in this term. This is nothing but Bayes theorem. What will say? Probability of y given x. This is same way probability of x intersection y. This probability of y came into this side, so it came into denominator. This is nothing but Bayes theorem. Probability of y given x equal to probability of x intersection y by probability of y. With the help of dependent event of the multiplication rule of dependent events, Bayes theorem came into the picture. Based on this Bayes theorem, naive Bayes machine learning algorithm also is there. Okay. This is the important topics of the probability. You need not to get confusion by learning more than these things. Okay. Thank you. Sorry. And also we can complete even permutations and also combinations. What is the permutations and combinations? It is a very known thing. Even in 8th standard, we all are learned this. So just I am going to revise this thing. So this is a permutation. Permutation means with help of two or more things, how many ways we can make arrangement, possible arrangements. So there are A, B, C, D. There are 4 letters are there. Using 2 out of it, using 2 out of 4 letters, how many ways we can arrange? So here permutation, the arrangement sequence will have the importance. So A and B is completely different from B and A. AB, BA. After that, CA. AB, AC, AD. AB, AC, AB, AC, AD. Then again, what is that? BA, BC, BD. Right. BC, BD, BA. So BA, BC, BD. CA, CB, CD, DA, DB, DC. Any other possibilities are there? No. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Total 12 permutations came. But in combinations, if we go for combination, it is just a combination. It is a combination of A and B means B and A also combination of A and B. So B and A equal to A and B, B and C equal to C and B, AC equal to CA. In that way, how many combinations we got it? Only 6 combinations. But if we go for permutations, 12 permutations, but 6 combinations. Always combinations are very less, but permutations are very high because each and every sequence also will have a different number, right? So what is the formula to calculate the permutations and combinations? Let us see. It is very simple. NPR is nothing but P is permutation. Okay. N is total number of things which we got it. R is how many we have to use at a time. So permutation is the arrangement of the items in which order matters, used for selection and arrangement of items. NCR is, it is just a combination only, right? So combination is a selection of items where order doesn't matter. This is only important. Order doesn't matter, here order matters. Okay. So NCR is nothing but n factorial by r factorial by n minus r factorial. But we have to keep in mind combinations anyhow, less number will come. Permutations, high number will come, right? So n factorial by n minus r factorial we have to do for permutations. This is high value it will give. Here, n factorial by n minus r factorial into r factorial. This r factorial is high. This r factorial is extra in the denominator. In denominator, one extra value is there, means automatically what will happen? The total value will be less, right? In denominator, very less value is there, so total value will come. This value will come little high. This value will come very low, as R factorial is in denominator. This is permutations and combinations. It is a very simple thing. Okay. Right. Thank you. Hypothesis testing. In another video, we have completed. Thank you.